what is a catalyst? A catalyst is any substance that speeds up the rate of a reaction without taking part in the reaction itself. It does not become part of the end products and remains unchanged once the reaction is finished.
You may never have heard of a catalyst before, but they occur everywhere in our day-to-day lives. Some examples include detergent and catalytic converters.
But let's get more specific. How exactly does a catalyst work? It lowers the activation energy required for the reaction to take place, and it can also act as a surface for the reaction to take place and allows more collisions to occur.
There are many ways that catalysts lower activation energy. One way is it changes the charge of the particles so that they become more attracted to each other.
This causes the particles to collide more frequently. Some catalysts also increase the local concentration of particles, and this increases their likelihood of colliding and forming a reaction. So we've already mentioned some of the examples of catalysts in our everyday life, but did you know that there are catalysts at work inside you right at this very moment? They help carry out a lot of different reactions that help maintain homeostasis in your body. Let's take a look. There we go. So as you can see, here, Lily's lunch is traveling down the esophagus and into the stomach. Now there are many catalysts that take place in the digestion of food particles. There are different enzymes that help digest carbohydrates, fats, and proteins. But let's take a closer look at how they work.
Here you can see the yellow lipid molecule and the blue enzyme. Notice how the enzyme fits specifically to the molecule, like a key to a lock. The enzyme then overcomes the bond and the lipid breaks apart.
So, let's look at an actual chemical reaction for catalysts. So here's just some everyday hydrogen peroxide, and we're going to mix it with some manganese dioxide. You should definitely try this under the supervision of a chemistry teacher, and definitely do not try this at home. So we're going to take about 100 milliliters of the hydrogen peroxide, and to it add just a tiny amount of the manganese dioxide. Let's take a look at what happens. Can you hear that fizzing? That is the release of oxygen. Now remember, the hydrogen peroxide was not reacting at all before we added the catalyst. The catalyst lowered the activation energy required for the reaction to take place. Let's take a look at the equation for the reaction that we just observed. Here is the overall reaction, and you can see that we added hydrogen peroxide, and it reacted to produce oxygen and H2O, or water. But where is the catalyst in this equation? Well, let's look below at the reaction mechanism for this reaction. There we can see the manganese dioxide at the beginning as well as at the end. And you can see that it has remained unchanged in our reaction. That is the definition of a catalyst. So now that we've looked at a couple of the examples for catalysts, let's think about the usefulness of catalysts. Think about them in the industrial or commercial sense. You have to create huge quantities of chemicals, and some of these chemicals require huge amounts of temperature and huge amounts of pressure in order to create in a timely manner. So can you see how a catalyst would be useful in this situation? As a catalyst speeds up the rate of a reaction, this means that higher yields of desired products can be produced in a faster, more timely manner. An example of a compound produced industrially with the use of a catalyst is ammonia. Ammonia is used for many things, such as fertilizer, glass cleaner, and explosions. We were not able to produce ammonia in large quantities until 1913, when Fritz Haber discovered the Haber method. This involved using a uranium catalyst to catalyze the reaction of nitrogen and hydrogen to form ammonia. Nitrogen and hydrogen would have not otherwise reacted and were very difficult to produce large amounts of ammonia. Nowadays, the catalyst iron or iron oxide are used to catalyze ammonia. Can you think of other pros for a catalyst based on the definition we provided earlier?
Well, Since catalysts are unchanged by the reaction, they can be used over and over again. This means that it's much more efficient to use a catalyst because you can just keep reusing it. Since you're recycling all these catalysts, it means that you're saving the environment.
Let's take a look at another way that catalysts can help the environment, in a catalytic converter. As you may already know, many harmful compounds are produced in the combustion of fossil fuels for our everyday uses, such as driving a car.
However, cars are built in with catalytic converters, which help change these harmful chemicals into less harmful chemicals.
Let's take a look at an actual catalytic converter. So here, we can see that harmful compounds go through this tube and into the catalytic converter.
Here they pass through a ceramic block which is coated in platinum. The platinum acts as a catalyst to convert these harmful chemicals into less harmful ones.
No carbon monoxide poisoning for you!
So, to conclude, catalysts are ever important in our day-to-day lives, in biological world, and in commercial and industrial fields.